Now then, this is PIC Computing, A-level computing video number 38. We're going to look at secondary storage in this video. Last time round we looked at primary memory and we found out that things like RAM, but not that type of RAM, this type of RAM is volatile, meaning that when we switch the power off to the computer we lose whatever is in RAM. Well, we're going to look at secondary storage now, and a great deal of this video will be the sort of information you won't need for the exam, but I think helps put secondary storage in a context for you. So we'll look at the exact things that you might need for the exam towards the end of the video, but I think you'll learn a lot in the meantime, and I think it'll help you figure out in your mind exactly the sort of things that they're going to be asking about in questions in the exam as well. So secondary storage, there are loads of different types of secondary storage. We know it's non-volatile because it's got to keep the data on it for a long time, even when a computer loses power. Because we store lots of files these days, such as images, videos, music, we need lots of secondary storage. Therefore, it needs to be cheap, and therefore it is slower than our main primary memory. There are three main categories of storage device, and the first is magnetic, and we might be talking magnetic hard disks or magnetic external hard disk drives. We might be talking magnetic tapes, which need to be put into tape drives like the one shown there. If we're talking optical, we're talking CDs or DVDs, and the newest form, the newest technology for storage devices is solid state. So we have solid state hard drives, USB data sticks, and memory cards such as SD cards. Quick bit about how each one works. Magnetic disks. There is a sort of cross section of a magnetic disk with the casing taken off. So you can see there are these different layers of disk. Every hard disk has many layers, each with this sort of needle on it. The correct terms are actually platters for the layers of the disk, and the read-write head for the little needle that reads the data on the disk. Each platter might look a bit like this and be divided up a bit like this. So each sort of layer, a bit like an onion layer, would be called a track, and then each wedge would be called a block, and then the cross section of those two, where a track meets a block, would be called a sector. And we might have the center of the disk known as the index track. So the reason that disks are split up in this way is that because they're so dense and they store so much data, this just helps the computer find out where bits of data are. And the index track helps things work quickly because the index track is the part of the disk that gets read the most quickly, and is a good pointer towards each block, because every block does channel into the index track, and is therefore a good pointer towards every sector where data lives. So it helps speed up searching for files on a disk. All these sort of hard disks need formatting, which means formatting means setting up each block and sector and track, and different operating systems require different types of formatting. So the same disk might be formatted differently from Windows than it might be in, say, Linux, and you'd see a different pattern of sectors, tracks and blocks for different operating systems. Magnetic tapes use similar technology, but if you were to reel out a magnetic tape, it would look a bit like that at the beginning, but would create a very, very long line of tape. It is linear. It has a huge capacity, but because it's linear, it's slow. The disk drive needs to go all the way through the tape to find a particular piece of data. Optical disks, such as CDs and DVDs, well, we've probably all seen the tray of a CD or DVD drive in a laptop, and in the middle there they have a laser. Now what the laser does is it reads the disk, and on the disk are millions of ones and zeros which are etched on, depending on the depth of the etching on the disk. So the laser will be able to determine whether it's a 1 or a 0, and that's how it reads the data from them. DVDs have several layers in the same disks. That's how they're able to store 4.76 megabytes, whereas a CD can only store 650-ish megabytes. There are different types of each disk, and you might need to consider these for exam questions. Just pause the video and have a look at those and see if they make sense. Solid-state disks have no moving parts, no mechanics, and therefore are less likely to break. And how they work is there's a really thin layer of oxide that is enclosed with two non-conductive layers. And this happens many times inside the disk. And the thin oxide layer stores the data, and it receives the data with little electrical impulses that are pulsed through to it. So that's, in brief, how a solid-state disk works. How do we judge secondary storage? Well, we judge it on capacity, speed, how fast can data be read or written to the disk, portability, how easy is it to carry around, durability, how sturdy is it, reliability, how long will it last. So those sort of things are some of the sort of things you might need to know for an exam. You'd need to know a definition of secondary storage, which might be an external peripheral or an internal component which allows the storage of data over a long period of time and is therefore non-volatile. But typically in an exam you'll be given a scenario and you'll have to justify some choices for secondary storage that a user might need. So, for example, a school might want to store pictures taken of a school fashion show with a digital camera. So what type of storage device would they use for that? Or a school wants to send a video of the show to parents and carers at homes. So again, which secondary storage device would they use for that? So that's typically the kind of thing you might get asked. I think a nice activity for people would be to construct themselves a table like that, so you could pause the video and build that table to find out things like cost, capacities, because cost and capacities and speed are always changing. We're getting faster, we're getting more capacity, and we're getting cheaper as time goes along. You could find those for all these different storage types, and you could also comment on portability, durability, reliability, and where each type is typically used. That would be a good exercise, and the sort of website you could go on to find this sort of thing might be eBuy, which is a really good value for money site, and you might search for something like magnetic tape, and there's one that's a terabyte now. You'll be able to find out speeds, certainly prices, and learn a lot more about secondary storage devices.